Can you imagine a life without water? It would be impossible, wouldn't it? The oceans cover most of the globe and play a crucial role in regulating our climate and atmosphere. Without water, life itself would be impossible. Our planet's distinctiveness lies in the abundance of liquid water. Many other celestial bodies and planets lack significant amounts of water, and when water is found, it often exists solely as perpetually frozen ice or as vapor within the atmosphere. In contrast, Earth stands out as a true water world. Its vast oceans blanket a substantial portion of the planet's surface and hold a pivotal role in the regulation of our climate and atmosphere. By the way, would you believe that the oceans cover 71% of the Earth's surface? As an illustration, approximately 66% of the Earth's landmass is situated in the northern hemisphere, leaving it with only 61% covered by oceans. Conversely, the southern hemisphere boasts around 80% of its territory submerged beneath the ocean's depths. Even though the oceans are traditionally classified into 4 large basins – Pacific Ocean, Atlantic Ocean, Indian Ocean, Arctic Ocean – these water bodies' masses are usually interconnected. The interconnections between the major ocean basins facilitate the transfer of seawater, substances, and certain organisms from one ocean to another. It is worth noting that the oceans are not merely areas where land happens to be submerged by water. The ocean floor is distinctly different from the continents in geological terms. It is engaged in an eternal cycle of formation and destruction, a process that shapes the oceans and significantly influences the geology and geological history of the continents. Geological events beneath the ocean's surface impact not only the oceans, but also the adjacent dry land. These processes that sculpt ocean basins occur gradually, spanning hundreds of millions of years. A common feature found on the ocean floor includes deep-sea hydrothermal vents and black smokers. So what are they? Stay tuned. One of the sections of the ocean is the mid-ocean ridge, which represents an exceptional environment within the ocean. As mentioned earlier, this ridge results from the upwelling of material from the mantle, elevating the oceanic crust. At the very heart of the ridge, however, the tectonic plates are diverging, creating a significant void or depression known as the Central Rift Valley, often described as an Earth's crust wound. The floor and walls of this valley are punctuated with crevices and fractures. Seawater infiltrates these fissures, gradually reaching extremely high temperatures as it comes into contact with the hot mantle material. Subsequently, the heated water exerts pressure to ascend through the crust, ultimately erupting from hydrothermal vents or deep-sea hot springs. The water emanating from numerous hydrothermal vents is moderately warm, ranging from approximately 10 to 20 degrees Celsius, significantly higher than the surrounding seawater temperature. In some vents, though, the water reaches scorching temperatures, soaring up to 350 degrees Celsius. Interestingly, these extreme temperatures presented a great challenge to early scientists attempting to measure the temperature of hydrothermal vent water. They found that common thermometers began to melt due to the intense heat in this area, and how are black smokers formed? As the heated water infiltrates cracks in the Earth's crust, it dissolves a variety of minerals, primarily sulfides. When this mineral-laden hot water emerges at the vent, it mingles with the surrounding cold water, rapidly undergoing cooling. This rapid cooling process leads to the solidification of many minerals, forming mineral deposits in the vicinity of the vents. Among the mineral deposits found at hydrothermal vents, black smokers are a notable type. These structures, resembling chimneys, gradually accumulate around the vents as minerals solidify. Interestingly, the smoke emitted is, in fact, a dense cloud of mineral particles. Initially, it was believed that hydrothermal activity was confined to mid-ocean ridges. However, hydrothermal vents, complete with black smokers and other mineral deposits, have been subsequently discovered behind trenches. These vents result from the same volcanic activity that gives rise to island arcs. Additionally, relatively cooler vents, with temperatures ranging from 40 to 75 degrees Celsius, have been found near mid-ocean ridges, though not directly at them. These vents give rise to chimneys primarily composed of carbonate minerals, stemming from chemical interactions between seawater and recently formed oceanic crust, rather than being a result of volcanic processes. Chimneys of this nature have piqued the interest of not just geologists, but also biologists. Among the most captivating discoveries in deep-sea marine biology is a towering vent that reaches a remarkable 60 meters above the ocean floor, establishing itself as the tallest known hydrothermal vent. A vitally important advance in deep-sea hot marine biology has been the discovery of unusually abundant marine life flourishing around hydrothermal vents. You will be shocked on the number of organisms that reside around these vents. Let me know what you think in the comments section, and thank you for watching and subscribing. Don't forget to check out my other videos.